Okay, so first piece of information we need here is what?
X plus Y equals 34.
You with me, guys?
Yeah, kind of not. I need more time.
This distance.
For honest.
We gotta get moving. You can finish her up on your own. Yeah, I know, but we got stuff to do today. So this is going to be 34 feet here. So x plus y equals 34.
So far, so good.
18 over 12 equals h over 18, which gives us that h equals 27 feet. So now I'm going to do this. This is x, and we're going to call this a. This we're going to call b, and this y, of course. So a plus b equals 27 is equal to h. And we have from this one here that 18 over 12 equals a over x. So 18x equals 12a. So x equals 2/3 a. So this is going to be 2/3 a here. Go where? To this? Yeah, cross multiply. Cross this way I get 18 times x is 18x. 12 times a equals 12a. So those two have to equal each other. 18x equals 12a. I divide by 18. 12 divided by 18 is 2/3. Now for this one here, it's 6/12. So I have 6 over 12 equals b over y. Cross multiplying there, I got 6 times y is 6y. 12 times b is 12b. 6y equals 12b. Divided by 6, y equals 2b. So I put 2b in here for y. So now I have 2/3 a plus 2b equals 34, and I have a plus b equals 24. 27, sorry, thank you. Now, watch your mouths, guys. I'm going to multiply this bottom equation by a -2, so I'm going to get negative 2a plus a negative 2b equals a negative 54. Top equation is going to stay the same. 2/3 a plus 2b equals 34. And negative 2a plus 2/3 a is negative 1 and 1/3 a. Negative 2 and positive 2b cancel out. Negative 54 and 34 making negative 20. So we shall divide by negative 1 and 1/3. You got it. Negative 20 divided by negative 1 and 1/3 is a positive 15. A is 15. So that means x is 2/3 times 15, which is 10. Now if a is 15, a plus b is 27, means b is 12. 27 minus 15 is 12. And y is 2b, so 2 times 12 is 24 for y. So x is 10, y is 24, and h is 27. What do you think? All stuff you guys can do on your own now? Yep. Have lots of fun with? Ready for your quiz? Just kidding. We're not taking a quiz today.
Oh. Are you handing it out?
Am I handing it out today? Yeah. Well, I might hand out the quiz today. Okay, so anyway, we're working on these packets. Let's finish this thing off today. If I can find where my copy of the packet is.
I have a copy like that. Or something.
Here it is. By the way, in the packet, number 79 in the packet. Make this explicit. The first person who can show me the correct answer get plus 30 points. Anybody thereafter can get plus 15 points. But you have to have every piece of it correct. Number 79.
Yep, I looked at that. I was just like, oh.
There are 7 pieces there you need to have correct. So anyway, we've got a couple of things we're going to talk about today. And we're going to polish this packet off so that we can do a couple of things next week to finish up the unit and take a unit test sometime next week. You want it, you know it. What's that? Oh, no. Oh. Gotcha. Okay, so anyway, be looking at number 79. It could be worth major points for you. I mean, 30 points is like a third of a test. It shouldn't take more than the weekend.
I mean, it depends on what your weekend.
It shouldn't take more than your weekend. So what we're going to look at today is fascia matches.
Wait a second. If you don't get them all correct, you don't get anything?
You got to have all 7 parts correct.
Otherwise you don't get anything.
There goes you get nothing.
Kind of hard, isn't
It is. It's extra credit.
it? Right.
Okay, so for fascia matches, what we're talking about with fascia matches, when you're looking at a truss, that truss sits on top of the wall. How do you spell fascia? Like that? Oh, well. So, the fascia sits out on the end of the tail of the truss. And usually what we talk about is your subfascia, which is a 2x6 or a 1x6. It gets nailed on like that. But what you run into is when you have a corner of the house. Like we looked at those L roofs a little while back. So if you're looking at that corner of the house, if you're looking into that corner like this, the fascia on one side has to match the fascia going the other way. So you have a continuous fascia, so you're not looking in that corner and the fascia all of a sudden, goes from here and drops down to like here or something. That doesn't look really good. You want that eave of the house to be uniform height all the way around. You want it to be continuous.
Okay.
But what we were looking at, we had L roofs that had a different slope than the main roof. And we had hip roofs that had different slopes from the main roof. Assuming that the walls are the same height throughout the house, which is hopefully a good assumption. If I have an L portion of the roof that is steeper than the main roof portion, if I have a consistent overhang distance here, what's going to happen to the height of this? It's going to be much lower, right? If it's steeper, it's going to drop a lot further in that same overhang than it does here. But we don't want that. So there are 3 ways we can adjust the height of that fascia. One way we can do it is to just adjust the heel height. Remember, this is the heel height here. So what we can do is we can actually take this board and we can lift it up like this so it's at the same height by creating a higher heel. Or, we can leave the heel the same and we can just cut back the overhang until we cut it back to a point where it's the same height. Or we could adjust the slope. Let's say we have a given overhang we want, we can adjust the slope to make it fit. You almost never adjust the slope. You almost always have a slope that you want, and you usually don't try to adjust the slope. The only time you really do a slope adjustment is when you have a spot where you want your eave to be at a certain spot to match another house, and you want this peak to be at a certain height, so you adjust your slope between the eave and the peak. You almost never adjust your slope just at the fascia itself.
I feel like that's also a lot of work to like adjust your slope.
Yeah, adjusting your slope is very uncommon. So we're going to look at, I'm just going to wireframe these. So for this first one, we have overhangs of 2 feet. My first truss here is what do I put on it? Let's put an 8-12 slope on it. This truss here has a 10-12 slope on it. Now I am going to go with a type, let's go with a type A energy heel. Energy heel means they go a little bit bigger. This is going to be the heel here, which is just the height from this point above the outside edge of the wall, remember. We're going to give that a 6 7/8 inch heel. That's a little bit off for a 8-12 slope, but it's close. So I want to know, I'm going to adjust the heel height here. I want to find what the heel height is that's needed to make the fascias match here to here. So I want to match across here. So we're going to assume that they are the same height. Is there anything else that we can assume is the same height? Yeah. We can assume the top of the wall is at the same height, right?
Why?
Hopefully. Well, if you're in a single building, hopefully your walls are all the same height. Yeah, if they're not, that really changes the calculation a lot. A lot of times if you want different ceiling heights, you actually put the walls the same heights, you put the trusses in, you actually false frame down to a lower ceiling. Unless it's like a whole wing of a building that's a different height, the whole addition, then you drop down. So if we know those walls are at the same height, what we're going to do is we're going to pick the truss that we know all 3 values. We know the slope, we know the overhang, and we know the heel for the one on the left here. And we're going to start at the top of the wall, and we're going to just call that a height of 0. Does that make sense? So the top of the wall is going to be our baseline. That's going to be 0 height. Our origin, if you want to call it that. Now we're going to go up to the top of the heel. What's this height at here? 6 7/8. And then we're going to go down to the bottom of the tail. Now we're going to have to do some calculation. First thing we need to know is how far did we drop? Well, this is 24 inches, I'm going to call it. Since we measured the heel in inches, I want to measure my drop in inches.
Where did you get the 24 from?
2 feet.
Oh.
So let's figure out what this is here. I'll call it A for now. We'll have 8 over 12 equals A over 24. A ends up being 16 inches, correct? So what that means is this point right here, the height of that point is 6 7/8 minus 16. Does that make sense so far? I was at 6 7/8 up here, and I dropped down 16 inches to get down to here. I was at a positive 6 7/8. Now I'm dropping down 16 inches. So it's going to put me down at a negative height. I'm below the top of the wall now. I'm at negative 9 1/8 inches. Now we're assuming the fascias match, so this fascia should also be 9 1/8 inches below the top of the wall, or negative 9 1/8. Does that make sense?
So when you're saying from the top of the heel to the bottom, it's not.
No, from the top of the heel to the bottom was 16. From the top of the wall to the bottom of the overhang is negative 9 1/8. Well, it's 9 1/8 down. From the top of the heel, which is right here, down to the overhang was the 16 inches.
Okay, and what is the 9 1/8?
The 9 1/8 is from the top of the wall down to the bottom of the overhang. That's here. Because this part was the 6 7/8.
Okay.
So now here, we want to figure out what the total rise is here. This is still 24 inches of overhang. This here's B. That's on a 10-12 slope. So 10 over 12 equals B over 24. Guess what B is? 20 inches. So we're going to rise a total of 20 inches here. But we started out at 9 1/8 below the top of the wall. So how far above the top of the wall are we?
Like 11,
9 1/8 plus 20 ends up being 10 7/8. Negative 9 1/8, I should say, plus 20, right?
Why 20, not 24?
Because you went up 20 inches. B is 20. What do you think? So what that means is when you order those trusses, you have to order them with a 10 7/8 inch heel, a custom heel, so that the fascias match, so you can keep the same overhang. You look confused, Mike. Should we do another example?
yeah.
Okay.
Wait, before you go, order it with, instead of order it with custom.
A custom 10 7/8 heel. That way we know when you install the trusses, the bottom of the tails will be at the same height.
Yeah.
And you'll be able to still have your 24-inch overhang all the way around. Otherwise, what happens if you order standard trusses, you'll end up cutting the tails off of these and having a shorter overhang on the steeper portion of the roof. And I don't like that look. Some people want that look. I don't care for it much. And you all know it's about keeping me happy, right? Okay. As long as we're straight on that.
Is that what you say the customers do, or?
Some days. By the way, I should note here, we always do a standard on the lower slope. Because if we did a standard on the higher slope and tried to adjust the slope, the heel height of the one at the lower slope, you end up with an impossible heel heights. You can always adjust a heel height larger, but it's really tough to adjust a heel height smaller. Does that make sense? No? If this is the standard heel height here, remember standard heel height comes, I have my bottom cord like this, and this is usually a 1/4 inch butt cut here. And I've got my 2x4 like that on top of it. I can't make, so my heel height is this right here. I can't make that smaller. You know what I mean? I can move this up like this and cut this out, and I can put a block in here to make it higher, but I can't make it lower. So that's why I always keep the lower sloped truss, you put the standard heel on it, so you can raise the heel on the upper sloped one. If you put the standard heel on the upper sloped one, the way to match it would be to lower the heel on the small slope, and you can't lower the heel. So we always start out with the smaller slope truss. So let's say that this one is a 412. So we have a 6 1/4 inch heel. And we're going to go with 18-inch overhangs. Over here, we also want 18-inch overhangs. Bless you. It's going to be an 8-12 slope. So again, we pick this to be our 0 point at the top of the wall. What we're really trying to find out here is how far below the top of the wall the end of the tail of the truss is. To do that, we find out how far it drops from the heel down. Bless you. This is 18 inches. So a 4-12 slope, we call this A again, equals A over 18. A ends up being what? 6 inches, right? So A only dropped 6 inches here. What that means is the tail of this is actually above the top of the wall. So my drawing here is technically incorrect. The tail actually ends up somewhere up here. How do I know that? Yeah, my heel height goes up 6 1/4 and I come back down 6 inches. I am still a 1/4 inch above the top of the wall. Do you guys see that? Can I know what I'm saying? So that means over here, this is technically a 1/4 inch above the top of the wall here. Oops. It has to be so that they match up. So now let's figure out how much this rises in my 18-inch overhang. Call that B. This is 8 over 12 equals B over 18. We end up getting that B has to be 12 inches. So how high is this heel? So this is a positive 1/4 inch plus 12 is 12 1/4. What do you think? That's kind of a crappy example because the end of our tail ended up above our wall. I'll do another one for you. Let's do one where the tail ends up below the wall. We're going to do a 5-12 slope, 24-inch overhang. By the way, it's very common to do an order of a 22.5 or a 22 1/4 inch overhang. Anybody know why? Anybody got a guess? 22.5 is the most common. Because you're going to add a 2x6 to it, which would make it 24, right? Okay, we'll just stick with standard 24-inch overhang. So anyway, you got a 5-12 slope, and we're going to call this a 6 5/8 inch heel. On this side, we have 24-inch overhang. We're going to have a 8-12 slope. Find what that heel has to be. So let's walk through it again. Of course, this is, what's the height here? Anybody? 6 5/8, just the heel height above the wall. So let's figure out how far we drop here. This is 24. Call this A. How do we find A? 5 over 12 equals A over 24. A is 10 inches. So what's the height right here? First of all, are we above or below the wall? We are below the wall. How far below the wall? 3 3/8 inches below the wall. So I'd either call it negative 3 3/8 or know that it's just 3 3/8 below the wall. I'm going to pause. Any questions on that so far? All I did was figure that my tail is 3 3/8 inches below the top of the wall. So that means over here, this tail also has to be 3 3/8 inches below the top of the wall. Because they match up across there.
3 3/8.
Yeah, 3 3/8. That was 5/8 here. We subtracted that from 6 5/8 minus 10 is negative 3 3/8. So now over here, got a 24 overhang. We'll call this B. 8 over 12 equals B over 24. Gives us that B is 16.
Yeah.
So then what? Contain your excitement, Drew. It's okay. Yeah, negative 3 3/8 plus 16, or 16 minus 3 3/8, however you want to look at it. 12 5/8 inches. Is that making more sense? So that's what I'm looking for, is what height. I got a special order this so that the heel is 12 5/8 inches, so I can maintain a 24-inch overhang and still have my fascias match. Let's have you guys try one. Am I sensing some back talk over there? This is 7/12. This is 12/12. Seven 1/8 inch heel. 18-inch overhangs. Give her a shot. Let's take a peek here. So, this is 18. This is A. 7 over 12 equals A over 18. Gives us that A is 10.5, correct? 10 and a half. So that tells us then that this here is 7 1/8 minus 10 and a half, or 10 and a half minus 7 1/8, however you put it, is going to be 3 3/8 below, correct?
Yes, sir.
So this is also 3 3/8 below. This is 18 inches. 12/12 slope means this is 18 inches. So that's going to be 14 5/8. Is it? Well, there's no systems of equations here. How about this one? Okay, so let's say we have a standard truss here with 24-inch overhang on this side, 6-inch slope. This is going to be a 6 5/8 inch heel. On this side, we have a 9/12 slope. We are going with a standard 7 1/8 inch heel. I want to know, what's the overhang got to be? Where are we going to have to cut that overhang off to make it match?
Switching it up.
So we've got our height drop here. This is 24 inches. We'll call this A. 6 over 24. Oh, 6 over 12, I should say, equals A over 24. So A is 12. So that means this point down here is 5 3/8 inches below. So over here, this is also 5 3/8 inches below. Yeah? So now, this height here is known. 5 3/8 plus 7 1/8 is 12 1/2 inches, correct? So we have a 9, 12 slope. We know a rise of 12 1/2. We are looking for the run, the overhang. So 12 times 12 1/2 divided by 9. Oops, helps if I get rid of the inverse normal there. So 16 2/3 inches. You are correct. Otherwise known as 16 and minus 16 times 16 is going to be 11/16. So here we had to stick with that common heel. What's going to happen is we're going to cut all of our overhangs off at 16 and 11/16. Probably 16 3/4 is where I'd cut them. A 16th inch of height isn't going to be seen, really. Does that make sense? We're going to take a break, and then you guys are going to come back in, and you're going to try one like that.
Wow.
Okay, so in your notes, try to find the overhang required to match these fascias. So there you go. We'll change that to a 10-12 slope. Find it. Okay, so let's see where we're at. "24 inches here. If this is A, how big is the drop for A? 6 over 12 equals A over 24. A is 12 inches. Puts us how far below here? 5 3/8 puts us how far below here? 5 3/8 puts us how big of a rise over here? 12 1/2. So then 10 over 12 equals 12 1/2 over OH. That comes out to be 15 inches. What do you think? Better than a sharp stick in the eye? Yeah? About the same as. We're going to look at hip rubs again for a minute. Yep. These are all things you guys know how to create, know how to calculate, but we're going to make sure you remember. So let's say that this is 36 feet. This is an 8-12 slope. This is a 12-12 slope. I want to find J, the length of the common rafter. I want you to find R, the length of the corner of the hip master. Z, the length of the longest jack. M, which is going to be located 10 feet from the end of the building. And N, which is the jack on this side that corresponds to that same spot.
That's all.
That's all. See if you can find those. Let's do this. So the first thing I'm going to find is J over here. To find J, of course, I need to know the height. You know, J is part of this common truss here, right? So what's its height going to be? That's an 8 over 12 equals blank over 18. So H is going to be 12. This is 12 feet high. This is 18 feet for my run. So 12, 18 equals square root of. So 21.633 is correct. I'm going to assume at this point you can convert it to feet, inches, and sixteenths. From that, then we're going to go to Z over here. To find Z, what do we know about Z? We know this is 12 feet high. How do I know it's 12 feet high? That's the height, same height as here. I can now find the setback. That's 12 over 12 equals the height of 12 over my setback. This is going to be 12. That's 12. So I got 12 here. So Z is going to be the square root of 12 squared plus 12 squared. 16.971. Feet. Now you can find R really easily. R can be found either by doing this triangle here. It would be the square root of 16.971 squared plus 18 squared. Or you could do this triangle here, which would be the square root of 21.633 squared plus 12 squared. Guess which one's going to be larger? Better be the same. 24.738. That is one way to double check, by the way. If you try that both ways and you don't get like within a few thousandths of the same answer, you screwed something up.
No way.
So M and N. To find M is not so tough, right? Because I've got my triangle for Z here. This is 18 feet. Z is 16.971. So to find M, I know this is 10 feet and that's M. So 18 goes to 10, and 16.971 goes to M. So 16.971 times 10 divided by 8. M is 9.428. How many people got that? In the real world, how many people got that? Yeah.
You go back up, I got confused by something. How did you get, okay, so that's what I was asking you, I was asking about the setback slope, right?
Yep.
That's the slope, the 12
That's the
over
slope of the hip.
Yeah, that's what I'm.
Krispy Kreme?
So this 12 over 12 equals 12.
What did, how did you get 16.971
I like the John C.
Well, this height of 12 was from over here, right?
Yes,
So then we got the setback is 12 from the 12-12 slope. We had a height of 12 and a 12-12 slope, so we did 12 over 12 equals 12 over 12 gives 12 here, and then as A squared plus B squared equals C squared. So we've got M equals 9.428. How do we find N? Well, we don't know this distance, do we? The distance from the corner up to N here. But the ratio of those distances is going to be the same as the 18 to 10.
I thought you said 10.
No, 10 this way. But we don't know this way. It's 10 from here out to M, but we don't know what it is out to N.
You
They match here, but the slopes are different, so they're not going to be the same. No. But we do know this is 18 feet here, right? The center. This is 12 feet. The ratio between the half span and the setback is the same as the ratio of these distances. So I'm just going to use those ratios. 18 over 12 equals m over n. Actually, the other way around. H is a 10 over our missing piece of x. So 12 times 10 is 120 divided by 18 is 6.66. That is this distance here. 6.667. Does that make sense now? Once you have that, then of course you just use this big triangle. This is 12, goes to the 6.667 is the 24, or not the 24, the 21.663 goes to n. You guys can find it from there. They do meet at the same plane at the top. They do, but they don't have the same setback because they're different slopes. It is, I know. Like I said, anybody want some extra credit, you can help make me some models in the shop. I've got my cardboard model that's falling apart here. Come see me and I'll show you what I want made for models. You can make them for me. Okay, last thing we want to talk about today. We talked about this briefly while you guys were on vacation. On the packet, the very last problems, 87 through 92. How many of you have all those done already? Wow, I kind of expected to see a hand. The extra credit on it? So number 88. I just want to take a look at this so you guys remember how to do this. Got 9 ounces over 3 gallons. We want to know how many ounces is that to 4 quarts. What's the problem? Can we cross multiply and divide?
Nah,
No, why not?
because they're not the same.
Not the same units. We do have ounces and ounces here, but we have gallons and quarts. I usually go to the smaller unit. That way my numbers don't get really weird decimals or fractions in them. So to convert gallons into quarts, what do? There are 4 quarts in a gallon, so 3 gallons become 12 quarts. So now I can cross multiply and divide. 9 times 4 divided by 12 is going to give me 3 ounces. Yay. A gnashing of teeth.
Todd, are you really fussy about how we do that? Like,
No, if you wanted to change this into 1 gallon and go that way, that works.
that you don't care?
As long as you get there, I will not tolerate round-off errors. So if you're converting to the larger unit, you might end up with a long decimal. Don't round it off. Keep it in the calculator. Because if you write it down and punch it back in, you can get a round-off error. And you might get like 2.98 or something. I'll mark that wrong.
Okay.
Mike, you have a question?
Could you have given us those answers before?
Yeah. Well, they were going to Vegas. We went over these.
Right.
I just wanted to do one problem to make sure everybody was on the page.
Right.
Okay, so you guys know everything you need to know to finish this packet. So the packet should be done. I'm not going to collect it. I will warn you that I'm not going to collect it. I am going to give you a quiz to take home over the weekend. On Tuesday, I will not answer questions on the quiz, but I will answer questions on the packet.